Okay, so this is page 201, and we're looking at exercise 2.2, question 1. So we've got that Charlotte claims that she can read Millie's mind. To test this claim, Millie thinks of a number from 1 to 5, while Charlotte attempts to read her mind. Charlotte is right on 4 out of 10 occasions. So the question's been split into 3 steps, okay, and these 3 steps you do for every question. But step 1A says write down the population parameter and suitable null and alternative hypothesis. So the parameter is always P for proportional probability. So in this case, it's the probability that Charlotte guesses correctly. Okay, and then the null hypothesis, what would we expect to happen? Well, there are 5 numbers, 1 to 5. We'd expect you could guess correctly 1 in 5 times, so a fifth or 0.2. So H0 is going to be 0.2. If Charlotte can read her mind, then we'd expect that proportion to be higher, so we're looking for P to be greater than 0.2. So there's your null and alternative. Then we're asked to define the test statistic and write down its sampling distribution under the null hypothesis. So if P is the probability that Charlotte guesses correctly, X is the number of times that Charlotte guesses correctly. Okay, and under the null hypothesis, X is binomially distributed. There were 10 experiments or 10 trials, so it's a binomial distribution. N is 10 and P is 0.2 under the null hypothesis. Okay, so that's parts A and B, and then part C, we're asked, are these results significant at the 5% level of significance? Okay, so we've got all the groundwork done. Now we're going to do the actual test. So remember I said it's always good to start with a diagram, okay, of a distribution. Just a picture to see what's going on. Okay, so here we have it. We are looking at one tail and we're looking at the upper end because it's greater than, so we're looking at this side, the right hand side, and it was a 5% significance, which means there's a value here X, and the probability of being greater than or equal to X is 0.05. Okay, now we're going to solve this particular question using the P value. So we need to know what X was in the question, and it says Charlotte is right on 4 out of 10 attempts. Okay, so your value that we're testing is 4, and what we want to know is the probability of being 4 or greater here, okay, or here? So are we going to reject the null hypothesis, or can we not reject the null hypothesis? So we need to look at the probability that X is greater than or equal to 4. Okay, so we can't do that on our calculator because calculators only do less than, so we need to do 1 minus the probability that X is less than or equal to 3. Okay, and if we look that up on our calculator, we get 1 minus 0.879, which is 0.1208. So the probability of being greater than or equal to 4 is 0.12. So where does that put 4 on my diagram? Okay, so this area here is 0.05. So if I had another value up here, the probability of being greater than it would be smaller than 0.05, and the value would be greater than X. Okay, now greater than or equal to 4 is 0.12 or 12%. So if this area is 0.05, 12% or 0.12 is going to have a bigger area. So we'd want a number somewhere about here. I'd expect 4 to be about here, so that being greater than it, okay, is 0.128, so we've got a much bigger area. So this whole area here would be 0.128. So we can see when we put it on our diagram that 4 is not in the critical region, so therefore we're not going to reject the null hypothesis. Okay, it's not significant enough, okay, to say that actually she's not just guessing. Okay, so the way we'd state this, so what we're doing is we're going to compare this is our p-value here. We're going to compare that p-value with our significance. So 0.1208 is greater than 0.05. Our p-value is greater than our significance. There is insufficient evidence at the 5% significance level to reject the null hypothesis. Okay, so in other words, we can't say p is greater than 0.2, so therefore we conclude that Charlotte cannot read Millie's mind and she is just guessing. Okay, so hopefully that sorted that problem out. I just want to have a look at the next 2 questions. I'm not going to do them, but just to guide you through them. Okay, so question 2, we've got last year 45% of students said the chicken dinosaurs in the school canteen were good value. After this year's price increase, Ellen says that fewer people think they are good value. She asked 50 people and found only 16 said the chicken dinosaurs were good value. Test Ellen's claim at the 10% significance level. So we're going to go through the same steps. We're going to start by defining the population parameter. So this is all about the proportion of students that said chicken dinosaurs were good value. So P in this case is the proportion of students that said the chicken dinosaurs were good value. Okay, now your null hypothesis is what we expect, and we expect that P would be the same as it was last year. So last year it was 45%, we'd expect P to be the same. And the alternative, well, this comes from the statement that says, Ellen says that fewer people think they are good value, therefore P is going to be lower than 45%. So there's your alternative. Okay, so that's that sorted. Part B, define the test statistic. Well, X is always the number of, okay, so in this case, it's the number of students that think their chicken dinosaurs are good value. And then the sampling distribution is always binomial. We've got P from the null hypothesis, and N comes from the number of people that were tested, which was 50. Okay. Then for part C, you're going to do the test. So if you remember, I said draw a diagram first. On your diagram, show where the critical region is going to be. We know it's 10%. Okay. And for this one, because P is less than, it's going to be at the lower end. Then you need to work out the probability, because it's a lower end test to the left. We're going to look at the probability that X is less than or equal to 16. Okay, so if it's an upper end one, you're always looking at greater than or equal to. If it's a lower end one, you're doing less than or equal to. So you need to find the probability that X is less than or equal to 16 and compare that with 10%. And like I said, if on the diagram you can show where 16 would be, that gives you a clue. But you're looking for the p-value, okay? If the p-value is less than 10%, you're going to reject the null hypothesis. If the p-value is greater than 10%, you can't reject the null hypothesis. So question 3, okay. Pete's Driving School advertises that 70% of its clients pass the driving test at their first attempt. Hattie and 3 of her friends failed, so we've got 4 people failed. 4 other friends did pass first time, so we've got 4 failed, 4 passed. She complained that the advertisement was misleading and that the percentage was actually lower. Test whether there is evidence to support Hattie's complaint at the 1% level. So again, whoops, one way round. We start with the population parameter, okay, which comes from this bit here, okay, and the null and alternative. Well, the null is what we're expecting to happen, so what's advertised. The alternative is, in this case, they think it's lower, so you're going to be P less than. Okay. Define the test statistic, which is the number of something happening, so it's the number of people that passed first time. And the sampling distribution is always going to be binomial. The N is how many people that we're testing. So we had 4 pass and 4 fail. So that's 8 people in total is your N. And then your P comes to the null hypothesis. And then again, for part C, draw a diagram, show where the critical region is. So it's one tail, it's a less than, so it's to the left-hand side. And this time it's just 1%. Okay. So the critical region is 1%. So again, because we're looking at the lower end, we're doing less than or equal to. Okay, so we're looking at how many people did pass first time. Well, it was 4. So we're looking at the probability that X is less than or equal to 4. And you're going to compare that value with 1%. So we'll just have a quick look at the next exercise because they're slightly different questions. So question 1, it says, in the past, 25% of John's violin pupils have gained distinctions in their exams. He's using a different examination board and wants to know if the percentage of distinctions will be significantly different. His first 12 candidates gained 6 distinctions. Test whether the percentage of distinctions is significantly different at the 1% level. So again, same principles, write down the population parameter and the null alternative hypothesis. So the population parameter is the proportion of students that gain distinction. So again, null is always what we expect, so we would expect it to be 25% or 0.25. And we're just looking to see if it's changed, not whether it's bigger or smaller. So we're just going to say that P is not equal to 0.25. So this is our two-tailed test. Okay, define the statistic. Well, the statistic is always the number of something. So it's the number of students that gained a distinction. And it's a binomial distribution. There were 12 students, so N is 12. And under the null hypothesis, P is 0.25. So then we're going to do the actual test at the 1% significance level. So again, get the diagram ready. So it's two-tail. So we've got critical regions both ends, but it was a 1% significance. So I need to split that 1% between the two ends. So we've got a 0.5% here, a 0.5% here, which is 0.005 either end. Okay. So what we're going to do is look at the test statistics. So in the question we're told his first 12 candidates gained 6 distinctions, so X is going to be 6. Now, I don't know where 6 appears, whether it's closer to this or this. Now at the moment my diagram is symmetrical. This distribution would not be symmetrical, it would be more very high here and then tail off that way. Okay. So we're not sure where 6 is going to occur. So we need to sort of work out what would we expect to happen first. So we need to work out the expected value, which is the probability, which is 0.25 times the number of trials. So it's going to be 12 times 0.25, so it's 3. So the expected value is 3. 6 is higher than 3, so we're looking at the top end. So we're looking at the probability of being greater than or equal to 6. Okay? So, looking at the probability being greater than or equal to 6, we can't do that on our calculator directly, so we have to look at 1 minus the probability X is less than or equal to 5. Well, less than or equal to 5 is 0.94559. So greater than or equal to 6 is 0.05440. So that's a small probability, but how does it compare with this probability? Well, this one, 0.05, is bigger than 0.005. Okay, so that's telling us okay, that 6 must be somewhere over here, because we'd have a bigger area above 6 than this bit here. So again, 6 is not in the critical region. Okay, so always write down the comparison to start with. We've got 0.0544 is greater than 0.005, so there is insufficient evidence at the 1% significance level to reject the null hypothesis. So the number of distinctions has not changed. Okay, hope that helps. Get back in contact if you're still struggling.